So this section is the compound angle section. Now this section is very heavy with proofs, and the first proof I'm going to show you here is the main one. Everything else then is a spin-off of that. Okay, so if I've drawn out a unit circle again, that's radius 1, that's radius 1. If I pick this point here and call it P, from what we've already learned, I can actually call that cos A sine A, and this whole angle here, the green one, is the angle A. Okay, so if that's the angle A, this is cos A and this is sine A. Now, if I call this one Q, so we've P and Q, I'm going to call this one cos B sine B, because this red section, just this angle here, is B. That's the angle B. Now this section in the middle, if the green section is A and the red bit is B, well then this bit in the middle has to be A take away B. So this section here, I'm going to call A minus B. So that's the size of that angle. Okay. Now the main objective in this section is I want to find a distance from P to Q. Okay, so I'll write it on the side. And there's two different ways we can find out the distance. So two different ways. The first one we're going to do is using the distance formula, basic enough. And the second one is using the cosine rule. Now I'll show you how to do both of those in a second. But what we're going to do is use both of these together to try prove our first compound angle formula. Okay, so now just using this one, using the distance formula, I'll use the blue for this one. The distance formula between P and Q is the square root of x2 minus x1 squared plus y2 minus y1 squared, and it's the square root of all of that. Okay, so we're going to call this one, x2 y2 and this one x1 y1. Okay, so now by replacing x with cos, we have x2, the square root of cos A minus cos B all squared plus sine A minus sine B all squared. And it's the square root of all of those. I'll jump down a bit of space to make a bit more space for it. So if we just expand this, we get the square root of cos squared A plus this multiplied by this twice, so it's actually minus 2 cos A cos B plus cos squared B. Okay, so cos squared A cos squared B minus 2 times the product, so it's minus 2 times those plus the same over here, sine squared A minus 2 sine A sine B plus sine squared B. So I just run a small bit of space. Okay, now that's the square root of everything. But instead of using this every single time, we're actually going to use PQ squared, which gets rid of the whole square root. So PQ squared is now going to come down as cos squared A minus 2 cos A cos B plus cos squared B plus sine squared A minus 2 sine A sine B plus sine squared B. It looks complicated, but it'll all fall apart now in a second. So from what we met in section 1, we've actually got a cos squared and a sine squared for A, and we have a cos squared and a sine squared for B. So if we link those together, cos squared A plus sine squared A plus cos squared B plus sine squared B minus 2 cos A cos B minus 2 sine A sine B. Now all I've done is just moved bits and pieces around to put similar terms together. From section 8.1, we found out that cos squared A plus sine squared equals 1. Same here, cos squared B plus sine squared B equals 1. So we now actually have 1 plus 1 plus, sorry, not plus, minus 2 cos A cos B minus 2 sine A sine B. Now if you're unsure of where this came from, just pause the video and you can look back again to see where each section came from. Now, so by cleaning this up, 1 plus 1 is 2, obviously. Minus 2 cos A cos B minus 2 sine A sine B. We can take out minus 2 as a common factor. So we'll say minus 2, open brackets, cos A cos B plus, because I've taken out the minus, minus has come out as well, plus sine A sine B. Okay, and that's as far as we can go for now. So this is the end of the first section. Now for the second section, we're going to use the cosine rule, which we've learned already is a squared equals, sorry, scribble that out, a squared equals b squared plus c squared minus 2bc cos A. Now if we go back to the circle, we're looking for this side, from this point to this point, PQ. So to find that side, that's going to be our side A. We need to have b squared, which is one leg of the side, which is length 1. We need to have c squared, which is the other side. BC is obviously 1 and 1. Cos A is going to be this angle, but in this case, cos A is actually A minus B. So if I sub all of that into this formula, I get PQ equals 1 squared. So we've PQ squared, which is A squared, plus 1 squared, plus 1 squared again, so B squared, C squared, minus 2 times 1 multiplied by 1, cos of the internal angle, which is A minus B. Cos A minus B. Okay, so now just cleaning that up, PQ squared equals 1 squared is 1 plus 1 minus 2 cos A minus B. Clean it up again, we have 2 minus 2 cos A minus B. Now that's as far as we can go with this section, so part 2. Now what I want to do is link part 1, which is here, which we did in the last section, to part 2, because q squared is equal to q squared. So in that case, we have 2 minus 2 cos A minus B equals 2 from here. 2 minus 2 cos A cos B plus sine A sine B That's now our equation. There's 2 on this side, 2 on this side, they cancel. So we have minus 2 cos A minus B equals minus 2 cos A cos B plus sine A sine B. And now minus 2 is common on both sides, so you can divide both sides by minus 2, and our final answer is cos A minus B equals cos A cos B plus sine A sine B. And that is the end of our proof. Now this is a very, very, very important formula, because in the later on formulas, when you're asked to prove the next few formulas, they all come from this proof. Okay, so you have to know this proof. From that section, the whole way down to here, cosine rule for the second part, and then the last little bit at the end. This is our proof. Now in the next video, I will go through the next few formulas and proofs and identities based off knowing this. So they'll be a lot shorter. This is the heaviest one to learn. We will get part 3, 4, 5 and 6 off of this one.